important. Please write the heading. Fire Savage law. Now, basically, what is this Bayard-Savart law? Basically, this law gives the magnetic field vector in the surrounding of a small or differential current carrying element. You know, this is very important to understand this particular thing. Suppose. Basically, what is this current carrying element? This current carrying element is it's a small piece of the current carrying wire. Basically, small element method. If you remember small element, so this current carrying element is basically a small element on the current carrying wire. Small piece of the current carrying wire. Please remember, this current carrying element, we generally consider it as a vector quantity. It's a vector quantity and its direction is same as that of flow of current. I told you it's basically a small piece of wire. So if it is a small piece of wire, then you know this will be dl vector. Okay, so basically the length, the direction, you always take in the direction of flow of current. So this is basically your current carrying element, and due to this current carrying element, whatever the magnetic field is created, that is what we need to study under Bayard-Savart's law. Is this clear? So suppose guys, there is a current carrying wire like this, a random shaped wire, whatever it is. And if I say there is a small current carrying element over here, the current is going through the wire in this direction. First of all, why do we need to take this current carrying element? Can't we take the direction of current? No, we cannot take the direction of current because current is a scalar quantity, technically speaking. Yes? Hello?
Yes, sir.
Current is a scalar quantity, technically speaking. So that's why we cannot take the direction of current. But current was important to determine the direction of magnetic field, right? So we devised a concept in which we will take the direction of current without mentioning the current is a vector quantity, right? So that is why we took length as a vector, and we'll just multiply with this thing, we'll get your current element. So is this clear, guys? Suppose this is a wire. Can you see a wire? Can
Yes,
you see
sir.
this part?
Yes, sir.
Basically, this part is your current element. The length of this part is how much? dl.
DL.
Well, I'll write it as dl, and the direction of this dl is from here to here, right? So can you see a small vector like this? Yes or no, guys? This is that
Yes,
current
sir.
element which we are talking about. Now, what is the magnetic field due to this current element? So basically, suppose if I would need to find out the magnetic field at a point P, then which is at an angle theta with the current vector. Can you see the current vector was going in this, you know, the current element was basically having this direction and R vector was having this direction. If I say the angle between them is theta. If I say the angle between them is theta, then acha, first of all, do you remember method 2 in the last class which we discussed? You apply Shivsar's snake rule. So what is
Yes,
the
sir.
direction of magnetic field
Yes,
at
sir.
point P due to this wire? Is it coming out of the plane or is it going into the plane?
Into the plane.
Into the plane.
Basically, this is your into the plane, and let's say the magnetic field is dB. So the magnitude of dB, do you remember? If this current is going like this, so if I say if the area of cross section of the wire is A, and the free electron density in the wire is N, and all these free electrons are drifting with a drift speed Vd, with a drift speed Vd in the direction opposite to the flow of current. Opposite to flow of current. Then can you see this wire? Only just you need to focus on the length element part. If I say this is the length element, can you see this is the length element, guys? The this is your dl vector. Thoda zoomed out view, right? So the current was flowing in this direction, yes or no? The current was flowing in this direction. So can I say the electrons are flowing in this direction with a speed Vd? Yes or no?
Yes, sir.
This is the current element. I am talking about the zoomed out version of this. So basically, can you see some charge is flowing through this particular thing? So do you remember that the last class we discussed charge flow, the magnetic field due to the flow of charge mu naught by 4 pi into qv sine theta divided by
R square.
r square. This was the magnitude, right? So can you say, guys, the Vd is basically in this direction, r vector is basically in this direction, and if I say this angle is theta, so what is this angle which is there between Vd, and if you remember I told you, this angle was considered theta, right? Here theta is basically the angle between current element and r. So basically dl vector and r vector, current element, dl vector, and position vector of point P. Are you writing alongside with me?
Yes, sir.
Yes, sir.
R. So basically theta is basically the angle between them. And what was this theta from the formula? What was this theta from the formula? Guys, what was this theta from the formula? It was the angle between velocity and the position vector,
The
right?
position vector.
So here in this case, this theta was basically the position that, so can you see this will be pi minus theta? Yes, although it won't make a difference because sine pi minus theta is sine theta only, but still technicality purposes only, enough. So when we apply this formula, if I say the total charge flowing is Q, so if the total charge in the wire is Q, if the total charge in the wire is Q, then can I say this particular thing? Charge will be equals to what? The number of free electron density multiplied by the volume of this. Yes or no?
Yes, sir.
The total charge will be basically what? Oh, sorry, not the total charge, the total number of electron in number of electrons in dl vector is basically the free electron density multiplied by the volume of dl vector. Yes or no? Because this is number of electrons per unit volume, if you remember from current electricity, right? So this total number of electrons will be equals to n multiplied by what is the area? What is the area, guys? Area was A. And what is the length? dl.
DL.
Yes or no? So this is the number of free electrons in the current element. Yes or no? So what is the total charge on current element? We're just calculating the magnitude because direction we already did, right? So the total charge on the current element will be how much? Total charge Q will be equals to this n number of electrons multiplied by E. Yes or no? Will this be your total charge on the current element? Yes or no?
Yes, sir.
Now after this, what to do? Now after this, the whole thing becomes very easy. Can you see from the formula for moving charge, magnetic field produced due to a moving charge, dB is basically mu naught by 4 pi qv sin theta r by r square. So I'll just copy control X and control. From the formula for magnetic field produced due to a moving charge, dB is equals to mu naught by 4 pi. What was the charge in this case? NaEdl. Yes. What was the velocity with which they were traveling? The velocity was
VD.
vd. What was the angle between the velocity vector and this vector? Velocity vector and this vector, position vector. I'll just cut and paste it over here only, where you can see it clearly. Okay. So can you see what is the angle now? Can you tell me what is the angle? Pi minus theta, right? So sine of pi minus theta and divided by r square. So can you see this NaEVD? What is NaEVD?
Current.
Current. So basically the magnitude is mu naught by 4 pi I. This dl will be remaining. So dl sine of pi minus theta is basically sine
theta
divided by r square. This is the magnitude of your magnetic field using Biot-Savart's law. This is your Biot-Savart's law basically. Using क्या? Magnitude of magnetic field due to the current element. So this is the magnitude, guys. Is this clear? In vector form, how will you write it? In vector form, dB vector will be equals to mu naught by 4 pi into I into dl cross r by r cube. Although we know we will never use this, right? Yes or no, guys? Will we ever use it? Guys, will we ever use it?
Because we'll be needing theta when you will cancel it.
Then never ever use it. You just use this thing to just get the direction of current. Can you see? Just focus on this cross product part. DL cross R. So basically you'll move your fingers of your right hand in the direction of DL and then move them towards R. Please note it down, guys. Let me just call. Hello. Done, guys? Guys, are you done?
Yes, sir.
Yes, sir.
South sir here. South sir. South sir. South sir, are you here? कोई बात नहीं. One of the students, from 12th grade got the result. तो उसी का कॉल आया था. ICSE student, Kavya. So she got 100 in maths, 97 in physics, and 93 in chem.
Damn.
सोच रहे हो तुम? It was nice. पढ़ाई करो भाई. सोच रहे हो? Finally, मतलब एक साल उसके पीछे बहुत मेहनत करी. The same thing we are doing for you people as well. But the point was she was not associated with us from 11th, right? तो सिर्फ उसका 12th में ऐसा है. Guys, most of us are aware, and guys, मेरे को एक और चीज बात करनी थी तुमसे. The new people who joined this year. Hello, guys, can you please keep your phone on unmute? I need to talk.
Yes, sir.
See, I am thinking कि मैं कैसे भी करके if I complete the syllabus of 12th grade by November, we can start with extra classes for 11th grade physics. मतलब basically Newton's
Okay, sir.
laws of motion and all, from November मतलब December onwards, right?
Okay, sir.
But उसके लिए है ना, और बाकी सब बच्चे जो already associated थे, they will get revision classes like that. So you can also sit in the same lecture. It will be a revision for you people. है ना? So the old students will
Yes,
have a
sir.
revision class like this, and the new students will be studying it, like properly. It will be like a crash course of kind of thing. But my focus will be like, if a JEE Mains 2021, and it doesn't get postponed in the month of January. So before that, we'll have to prepare each and everything. Please remember, अभी आपका जो syllabus थोड़ा सा reduction हुआ है. There is a small reduction in your this thing. And by the way, please remember, those are the deleted portions. I think still people have confusion in this. They are just reading the chapter name and that's it. Whole chapter is not emitted. Only some topics are emitted, and they have mentioned those topics. Like for example, electrostatic, they removed the electric field due to a charged thin shell. Only that topic was removed. Gauss theorem is there, electric potential is there, capacitance is there. Are you getting my point, guys? कल मेरे को
Yes,
Yes,
sir.
sir.
first or second chapter it was removed. No, first and second chapters are not removed. Only certain topics are removed, and that too only school point of view. The NTA has not given anything on the, because the syllabus for JEE and NEET should remain same. Abhi tak there is no update on that. Otherwise, if CBSE would have done that, then NTA would also have done that. Ki ha, we are also decreasing the syllabus for JEE 2021, but they have not given anything like this. Okay, so don't think like
Yes,
if
sir.
school में
Okay, sir.
portion कम हो गया है तो we need to study less. No, we need to study still that much only. Okay, so एक थोड़ा सा मेरे
Okay,
को
sir.
थोड़ी बहुत बातें करनी थी 11th grade की class के regarding, and for old students it will be revision classes, the same classes only, and new students it will be like complete conceptual lectures and all. So this will be done in December. One thing more, and apart from this I wanted to talk एक और चीज. What was the second thing? This related topic. Okay. So done. Let's come back to the where we left off. Now, so we are clear about Bayes-Savitz law. Let's start about the application of Bayes-Savitz law. Applications of Bayes-Savitz law. These applications are important. Guys, do you remember electrostatics? There were many different formula. Yes or no? The
Yes, sir.
same type of this thing will come. Same type of applications and same type of formulas will be there. We'll be deriving those formulas again using something called as Ampere's circuital law. Okay, do you remember the symmetry? Initially we started Gauss theorem, and from that Gauss theorem we derived different formulas for electric field, right? Yes or no? So here
Yes, sir.
magnetism, the same thing is Bayes-Savitz law. From that Bayes-Savitz law we'll derive different formulas, and then in electrostatics, if you remember, after studying Coulomb's law, we discussed Gauss theorem, and we discussed again the applications of Gauss theorem, right? So here also there is something called as Ampere's circuital law, which is again a substitute for this Bayes-Savitz law, only symmetric cases. So the chapter first which we studied and chapter 3 which we are studying, the unit 3, they are analogous to each other. Try to find this analogy. Okay, I'll try to connect it between. Okay, I'll tell you where the formulas are similar, where the formulas are different. So don't worry. Is this clear, guys? I'll be
Yes, sir.
connecting between both electrostatics and magnetism, so that you'll understand the symmetry between both of the different branches. Okay, let's do first thing, magnetic induction due to magnetic field intensity due to a current carrying finite wire. Finite wire basically is having certain length, right? So suppose, guys, let us consider a wire. This is this derivation is not there in your school. Finite is not there, but infinite wire is there. Okay, so the steps are same, only what will change in finite and infinite? What will change? What is the only thing change which finite and infinite? The limits, right? Does only the limits change?
Yes, sir.
So suppose, guys, there is a current carrying wire, and you are requested to find out what is the magnetic field at a point P which is having a perpendicular distance r. So let us consider a wire carrying a current I. So what is the current carrying in the wire? The current is I. Yes. and let's say the angular limits is basically alpha n. What are the angular limits? The angular limits are alpha and beta. Guys, do you remember this alpha beta? Can you see the correlation?
Yes, sir.
Line charge. एक line charge है. There is an infinite a line charge is there, alpha beta. ये सब कुछ याद आ रहा है? Already we did this. How did we do it
Yep.
in this? Let us consider wire carrying a current I from this wire at a point P. At a perpendicular distance. We need to find the guys, don't write, na 2 minutes. We need to find the magnetic field from this wire at a perpendicular distance r. This is what it is. So basically we need to find the magnetic field from this wire at a point P at a perpendicular distance r from the wire, right? Please remember this is a straight current carrying wire, okay? It's a straight current carrying wire. So let us consider this done. Right till here, please. And now, how will we do it, guys? How did we do the variable cases? Can you see? You don't have any formula for this whole wire, right? You just have the formula for a small element.
Small element.
So basically, we'll consider a. Can you see a small element dl vector, which is making an angle? Theta. Will it be confusing to you Where should I take the theta? I should take the theta from here, not here. This will be. Guys, suppose है ना with theta am I taking? थोड़ा सा confusing. It may get a little bit confusing to you people. But can you see this element was at an angle theta from here? Why have I taken theta from here? So that I'll get positive and negative accordingly. Okay. Let us say this distance is L. This distance is small l, and we have taken an element of length dl, right? Right, guys?
Yes, sir.
Yes.
Now, can you tell me what will be the direction of magnetic field at this particular point? Direction is very decided, right? Will the direction be like this? Do you have any doubt in the direction part? That is why I teach the laws first, so that at least you will get बाहर जाके बात करो दो कब से चिल्ला रहे हो? So is this clear, guys? The direction
sir.
part, I guess it is pretty much clear. You can use your right hand thumb rule, or you can use SSS. Is SSS effective as of now? Directly cut karke you can get the direction of magnetic field, right? So we will be at inside. Let's talk about the magnitude. What will be the magnitude? First of all, can you see this small triangle being formed? The blue triangle, there was this dl length, but dl is very small as compared to l, right? So we don't require that. Theta and l. So can you have a relation between l, r and theta? Can I write l is equals to r tan theta? Can I write this, guys?
Yes, sir.
Okay. So from here, can I write dl is equals to r? What is tan theta ka differentiation? Anyone?
Sec square theta.
Sec square theta, and then ultimately you'll write d theta at the end. Sir, where
D
did
theta.
this d theta came from? It was over here, dl upon d theta. Are you getting my point?
Mm.
Then from this dl upon d theta, we transferred this dl towards and multiplied it over here. Ovia, is it clear? Hello?
Yes, sir.
So
Yes,
this
sir.
this is your triangle, the small element. This was your small element here, but we don't require it as of now. Now, what is the magnitude of this magnetic field due to this small elemental y? So we know the formula mu naught by 4 pi I. What was the length of this wire? dl into sine of theta. But do you remember sine theta was basically the angle between the current and the position vector, right? So basically this angle would have been chosen as theta. But since we already named this as theta, then what will be this? Will it be 90 minus theta? Will it be 90 minus theta?
Yes, sir.
So please remember here in this case, dl vector is in this direction and r vector is like this. And this angle between them is pi minus theta over here. So that is why in sine theta, what we will write? Sine of pi minus theta divided by, what is the distance? Yes. Can you see over here the distance from here to here? Can you see L R? Will it be equals to under root of L square plus R square? Whole square. Will it be like this? Guys, did you understand the application of formula? Shall I go again? The only two things over change, we modified over here. Can you see mu naught 4 pi I dl to is common? Then sine ke baad mein there was theta. What was theta in the formula? Theta was basically the angle between the dl vector and r vector. So since we have chosen theta like this, hence what will be the angle here? What is the angle between dl and r? Pi minus theta. Shall I write it over here? Angle between dl vector and r vector is pi minus. Is this clear?
So isn't it pi by 2 minus theta?
Sorry. My bad. Pi by 2 minus theta, 90 minus theta, right? So this will be also 90 minus theta. Yes or no? And this distance from dl vector to that point, will it be this by Pythagoras theorem under root of L square plus R square? So under root of L square plus R square ka whole square, because it was. Are you getting my point, guys?
Sir,
Yeah.
Bolo.
sir, can you explain again why do we take it as 90 minus theta?
Because we have taken theta from where? Can you see we have taken theta from the horizontal over here?
Yes, sir.
So basically this is the theta we have chosen, then our equations will be in terms of this theta. But when we are applying the formula, we wanted this angle which was between dl vector and r vector.
Okay,
So
sir.
from this triangle only, we said that this angle between dl vector
Oh,
and
okay.
r vector is pi by 2, 90 minus theta. So we wrote 90
Okay, sir.
minus theta. Okay.
Got it.
And why did we
Yes, sir.
wrote this as under root of L square plus y square? Because under root of L square plus r square, Pythagoras theorem, right?
Yes, sir.
There is a pen. Yes, so this is under root of L square plus r square. So this distance we wanted, the element and the particular point, right? So under root this ka whole square. After this, what to do? Ab sirf we need to solve it. So the magnetic field due to the current element at point P or in spite of writing it over here, I'll write it over there. So that at least you will remember why did we take pi by 2 minus theta. put it together. Is it clear now? Okay, why did we use pi by 2 minus theta in place of theta over here? Because we wanted the angle between real vector and r. Every step should make sense, otherwise there is no point of doing the derivation. Okay? So once
Yes,
you are
sir.
done with this thing, let's solve it a little bit. So dB is equals to mu naught by 4 pi into I dl sine of, what is sine of 90 minus theta? I think it is cos theta, right? On solving,
Yes, sir.
we are getting this. And here it will be under root of L square plus R square, nothing else, right? Yes or no, guys? Yes or no, guys?
Yes. Yeah.
Now see over here, dB will be equals to mu naught by 4 pi into I into what is dl, guys? Can you see dl? Can you see in place of dl I'm writing this thing using that relation? So r sec square theta d theta into cos theta divided by what is L square plus R square? So can you see L square? I can write it as R square tan square theta plus R square. Yes or no? Can I write it like this? Basically, in place of L, I have substituted the values of in terms of R. Can you see this, guys?
Yes,
So
sir.
dB will be equals to mu naught by 4 pi. Can I take R square common from the denominator? Guys,
Yes, sir.
take r square common from the denominator and cancel with 1r in the numerator, so only what will be remaining in the numerator? I in the numerator and 1r in the denominator. Yes.
Yes, sir.
And what else will be remaining? Can you see sec square theta and cos theta? So can you see over here, this will be, can I write 1 sec theta, or can I cancel 1 sec theta with cos theta? Because we know sec theta is nothing but 1 upon cos theta. Everyone remembers this, right? So can you see when you multiply sec theta into cos theta, so this cos theta in the denominator and that cos theta will get cancelled out? Yes or no? So I'm cancelling out this cos theta and 1 sec theta from here.
Tan square theta plus 1, you can write it as 6 square
Sec
theta.
square
Yeah.
theta, and then I will cancel that as well. Don't worry, I'll cancel that as well. Enough? So I'm writing this as r, sec theta d theta, and here in the denominator you'll get tan square theta plus 1, which can be written as sec square theta, as 1 plus tan square theta is 6 square theta. Yes? Can you see tan square theta plus 1 will remain over here? That will become 6 square theta, and now you'll cancel 1 sec theta with 1 sec theta. So this is 1 upon sec theta into d theta, and finally you get this thing, dB is equals to mu naught by 4 pi into I by r cos theta d theta. Can you see? It has been simplified to this form. On applying Bayes-Savitz law, it gets simplified to this form. Yes? Yes or no, guys?
Yes.
Now see this particular thing, all the elements will have magnetic field in that direction, only in the direction of B, which I have given over here. So basically when I integrate the magnetic field at this particular point due to this element, will I get the total magnetic field due to this whole wire at this point? So basically we need to do what? We need to do integration. So on integrating both sides, we get, what is the integration of dV? B, and this will be mu naught by 4 pi constant. Current was constant, the distance, perpendicular distance was constant. What will the only thing which will remain in the on the right hand side under the integration side? Only this. After this, sir, what we'll do? After this, what will we do? Basically what we will do, Can you see over here theta, right? You will put the limits from plus alpha to minus beta. You remember the same thing we did in electricity, plus alpha minus beta?
Yes, sir.
So the same thing. What is the integration of cos theta? Yes, who will tell me what is the integration of cos
Sin
theta?
theta
Sin theta. Is it minus sin theta or plus sin theta?
plus sin
Plus
theta.
sin theta. Chalo, sahi hai. Up you people don't get confused in plus, this normal thing, right? Bio students
Sir,
especially. Bio students. Yes.
sir,
Ah,
sir, I have a doubt. Why don't
ah.
we take it as plus alpha to minus beta?
Because can you see over here, theta was basically taken from horizon over here. Can you see the vertical part? So if you want to look at the top point,
Yeah.
you need to suppose you are standing at point B, and if you want
Okay.
to here you are standing, okay, and if you
Okay,
want to
sir.
look at this point, so do you need to raise your head or down your head?
Raise my head.
Raise my head. And similarly, if you need to see this point, then you need to down,
Yeah.
yes or no?
Lower my head.
Lower
Yes,
my
sir.
head. तो मेरे को एक बात बताओ कि कभी if it going up and down, is it in the same dimension? No, right? So it's
No,
one time
no.
you are going up, one time you are going down. It's in the opposite
Going
direction,
down.
right? So that is why you are taking one as
Okay.
plus and one as minus.
Okay, sir.
So is this clear, guys? And then when you write it, the final answer is I by R. Oh, mu naught by 4 pi into I by. Never ever solve this, guys. Even if there is a 2 or some constant out, never solve this. Okay, let it be like that. Remember the last term. So I by R into sine alpha plus minus sine of minus beta. Yes or no? So when you solve it, the final answer you get mu naught by 4 pi I by R into sine alpha plus sine beta. Yes or no? Any doubt, guys? Is it, sir, this formula looks similar? Yes or no? And what is the direction? Acting in this direction for this wire, right? Here, if you have a finite wire, of carrying current I, distance R, and this angle is alpha, this angle is beta, then the magnetic field direction will be given like this, and the magnitude of magnetic field will be mu naught by 4 pi into I by R into sine alpha plus sine beta. And in electrostatics, if you had a line charge, with linear charge density lambda coulomb per meter, okay, and the same distance r, the same alpha and same beta, here you had two different components. If you remember, there was this E perpendicular and there was this E. Always remember, E parallel was always on the towards the shorter side, if you remember. Yes or no? What was the formula for E parallel and E perpendicular? Guys, does anyone remember? E parallel was K lambda by R. Well, what was K?
1/4 pi epsilon naught.
K lambda by R. Can you see the similarities now? अब दिख रहा है कुछ? And E perpendicular was 1/4 pi epsilon naught lambda by R. This was sine alpha plus sine beta. Can you see the similarity now, guys? Can you see the formula is almost same? Mu naught by 4 pi, 1 by 4 pi epsilon naught to constants. Yes or no? I by r, lambda by r, and sine alpha plus sine beta, sine alpha plus sine beta. Can you see the analogy? Hello guys.
Yeah,
Can
makes sense.
समझ हाँ बोलो. Any doubt?
No, so I just said it makes sense.
So is this clear, guys? Is this clear? Any doubt?
Sir,
हाँ बोलो.
sir, in all cases we take parallel in that direction and perpendicular to this direction.
In all cases, no. We basically, can you see this side? This side I draw shorter. Always remember, E parallel is always towards the shorter side. If this charge is positive, then E parallel is towards the shorter side. If this is negative, E parallel is towards the longer side. Do you remember I gave you this type of convention? If you revise
Yes,
electrostatics,
sir.
then you'll see everything is there over there. मैं बहुत I teach in a lot detail. इतना मेरे को पता है. That is a feedback
sir.
which I know. You can never say कि sir you never taught me this.
No, sir. You taught it.
नहीं, I generally मेरा शुरू से ये रहा है. मेरे साथ है ना, एक बार ऐसा हुआ था. When I was teaching in my first year, you wouldn't believe, first day there was a guy who wanted to check my knowledge. और although मेरे को उस टाइम पे आता भी नहीं था. First day when I went back to India from here, after first day as my senior faculty, and a student came up to me and asked a doubt from Irodov. Irodov is a god level book. Even the different faculties, they don't try to do that, but वो solve करके बैठे हैं, है ना? It's from a Russian author, I.E. Irodov. मत करना, depressed हो गए. You people don't try it, है ना? Engineering students, I'm telling you, don't try I.E. Irodov because you will get depressed, and I don't want you to be depressed, है ना? So anyways, तो वो solve करने के लिए बच्चा test करने के लिए, sir question I couldn't solve, obviously first day as my senior faculty I don't know stuff. How would I able to solve? How would I be able to solve? तो फिर मैंने उसको बोला कि भाई मैं अगले दिन बताता हूँ तेरे को थोड़ा देख के. I don't know how to do it now. I'll check it home. Its solution is available online. I'll understand it and then I'll tell you. तो बोला ठीक है सर. Next day गया घर पे पूरा पढ़ा and gave him the solution. Then I realized कि bro, I'm a teacher. I don't know. If I would not know, then how am I supposed to teach you people? Are you getting my point? So उसके बाद मैंने पढ़ना start किया and I made like 25 kg notes. But my notes, if you weigh them total 11th and 12th grade, all handwritten notes are 25 kg. I'm not measuring the knowledge by mass, the unit of mass, but बता रहा हूँ मैं. मेहनत बहुत सारी करी है मैं. Anyways, so is this clear, guys? So this was for finite. And how will you give the direction using SSS rule, right?
Yes, sir.
Or right hand thumb rule? It's up to you. Whichever you feel comfortable, that is important, है ना? Now, if I have infinite wire, finite wire, तो done. So if I do special case, number 1, for an infinitely long current carrying wire. So alpha will be, if I have an infinitely long current carrying wire. So can you see over here? This will be R, this will be that point. What will be the direction of magnetic field? Inward or outwards? Into the plane, out of the plane?
Into the plane.
Into the plane. This is the direction of magnetic field. Here in this case, if you want to see that end, how much high do you need to lift? What is the angle by which you should move your head? Will it be 90 degree? And will this be also 90 degree? So basically, you'll get mu naught, the magnetic field as mu naught by 4 pi into I by R. And what will be sine alpha plus sine beta? Can you see both will be 1, right? Sine 91, sine 91. So 1 plus 1 will be 1 plus 1 will become 2, right? Arey हाँ या ना भाई? So the final answer is
Yes, sir.
twice of I by. You just need to remember this. You just need to remember this. Do you remember when you had an infinitely long line charge? What was the electric field? What was the electric field? Electric field only had a parallel component, right? And what was the
Yes, sir.
total electric field at this particular point? It was, if you remember, it was twice of k lambda by r, 2k lambda by r. Yes or no? So can you see k?
Parallel or perpendicular component?
Oh, my bad. My bad.
Perpendicular.
Perpendicular. So 2k lambda by r. So can you see k 2 I lambda r? Can you see the analogy again?
Yes, sir.
So ये थोड़ा सा ध्यान रखना. Okay.
Okay, sir.
Not every case will be similar, but most of things you will find analogous. Okay. अब जैसे for example, if I talk about what half wire है ना, semi-infinite wire near one of its ends. So basically, if I have a wire which is like this, it is going infinity from one side, or it has come infinity from one side. It's a whatever, it depends upon the question. Suppose now, can you see near its one end I want what is the magnetic field due to this infinitely long current carrying wire? So the magnetic field direction will be,
Into.
and B will be equals to mu naught by 4 pi into what will be alpha over here? Alpha will be,
Alpha
90.
will be 90, beta will be 0.
0.
or you can do the opposite one as well. If it's this case or this case.
Then alpha will be 0, beta will be 90.
Are you getting my point now? In both the cases, in both these cases, B is equals to mu naught by 4 pi. I'll write alpha beta here. In this case, this is happening, and in this case, alpha 0 and beta 90. So mu naught by 4 pi into I by. Is this clear? In both these cases,
Yes.
this will be like this. And why did I? Okay, is this clear?
Yes, sir.
Here also the direction will be. So what happened in the analogy? What happened in the electrostatics? Does anyone remembers?
So it's root 2 k lambda by r.
In electrostatic, it is root 2 k lambda by. Why does this happen in electrostatic? Because electrostatics में जो electric field, can you see the guy? एक और चीज है. Electric field is in the plane, if you remember. In case of electrostatics, was it like this? This was also k lambda by r. This was also k lambda by r. Hence, the resultant was E parallel, and this is equals to K lambda by R, and then the resultant was root 2 times of K lambda by R. ये याद है आपको? This was the net electric field, right? So can you see? Still, can you see this part? I told you no. Can you see B is basically symmetric to E parallel? Sorry, E perpendicular. B is symmetric to E perpendicular over here. Can you see? And here in this case, what is the answer? Is this clear, guys? समझ में आ रहा है थोड़ा बहुत? Are you understanding the
Yes,
application
sir.
part?
Yeah. Yes, sir.
Now, this is the semi-infinite wire is done. Third case. नहीं बाकी सारे केसेस तो जनरली हो जाएंगे इसके आई गेस. Let me check. Case 1 is infinite finite wire. This is done. Case. When guys, this is very important. Suppose whether this is finite wire, infinite wire, doesn't matter. If you have the object or if you have the point on the axis of this wire, when point P or basically the magnetic field on the axis of a straight current carrying wire.
It's 0, right?
क्या हुआ?
It's 0, right?
It is 0. So basically, if I want to find out whether this wire is finite, infinite, semi-infinite, doesn't matter. If this magnetic field is lying on the axis, please remember, if it is lying on the axis, that doesn't mean it should lie anywhere where the wire is present. Okay? Wherever the wire will be present, the magnetic field will become infinite. But it is lying on the axis away from the wire. Okay? Is there a difference? जैसे P and can you see a point Q? Can you see P point is lying on the axis, whereas Q point is lying also on the axis, but lying on the wire as well. Are you getting my point, guys? Hello?
Yes.
Yes.
So always remember, magnetic field on the axis of a straight current carrying wire, this is P at point P, will be always 0. Why it is 0? Because in this case, alpha and beta both are 0. Okay? Is it clear? Is it clear, guys?
Yes, sir.
Yes, sir.
After this, let's do this. Next heading, right? Guys, the second application. This was the first application, magnetic field due to a straight current carrying wire. Now we'll write the second application. What is the time? 15:42. When does the class end? 4 o'clock, no? But we'll end it 10 minutes later because we started 10 minutes later. Right?
So I think maths sir wanted to start class at 4. I don't know. I'm not sure.
I need to check with him. ऐसे तो मैंने नहीं देखा है अभी तक ऐसा मैसेज.
So today's class is from 4.
चल देखेंगे. If that's her messages, then I'd join at 4. Join now something. So we'll end the class. No problem. Okay. So next second application is basically magnetic field due to a current carrying circular arc. So basically, if I have a wire which is in the form of a circular arc, can you see this wire now? And I want to find out what is the magnetic field at the at its center. I want to find out the magnetic field due to current carrying wire at its center. So basically I need to find it over here. Let's say this wire is of radius r. Yes or no? Hello?
Yes, sir.
Yes,
So
sir.
suppose if this whole angle is phi, then what will be this angle? Shall I make it a little bit bigger? Let me make it a little bit bigger, guys. Can you see a circular arc now bigger, a little bit bigger?
Hmm.
This total angle is basically phi. What is this line? This line is basically the angular bisector. Phi by 2 and phi by 2. Okay.
Yeah.
Now, if I want to apply Biot-Savart's law, then what will I do?
Take a small component.
So basically, I'll take a small component. Can you see the small component dl vector?
Hmm.
Let us say this dl vector is taken at an angle.
So we can consider dl vector to be just the direction of current at that point, right?
Bus. Why a dl vector? Actually,
Hmm.
dl vector is that only. Dl vector is just
So
made it so
dl
that it
doesn't
can
make
consider the
sense.
direction of current.
Yeah. Okay. And if they have given us electron flow, then it will be opposite, right?
It will be in the opposite flow of electrons.
Okay.
So is this clear, guys? ये आपको समझ में आया? What have we done? Shall I write the whole thing? Is it fine? This is not part of your school syllabus. Is it there in your school?
No,
So,
sir.
I don't think so. No? So I'm not writing the whole. Let us consider all things and all. Now see this particular thing, guys. Basically, now what you do? Can you see due to this thing? This dl vector is like this. Yes or no? And can you see from this dl vector to this particular point O where we want to calculate, will this be your r vector? Yes or no? Yes or
Yes,
no,
sir.
guys? What will be the
Yeah.
angle between dl vector and r vector here? Can you see this is tangential? Dl vector is tangential, whereas this is radial. Yes or no? So here, what happened? So here dl vector is this, r vector is like this. Now what to do? What to do, guys? Now dB will be equals to mu naught by 4 pi I into dl into sine theta, right? So what is the angle? Yes, guys, what is the angle? Hello, guys, what is the angle? Hello.
90.
So sine of 90 degree divided by what is the radius? R square, right? Yes or no?
Yes, sir.
If I
Yes,
say
sir.
that this dl vector is subtending a small angle, can you see the green is different, hai na? The red part is just for limit. The green part is basically the element which we are choosing. So can you see the element has a small angle d theta? Can you see this d theta? This angle, which this element is subtending at the center. So basically, if I have this, basically this angle is your d theta. Are you getting my point?
Yes,
Yes or
sir.
no?
Yeah.
So basically, this is the radius. Can you see the position vector? The magnitude is basically equal to r. The magnitude is equals to r, and this is the length of r. So I can write dl as r into d theta. If someone remembers, angle is basically what? Do you remember the definition of angle? Angle is length of arc upon radius.
L by R.
So dl is equals to r into d theta. So can you see db is equals to mu naught by 4 pi into I into r upon r square d theta. Sine 90 is 1. 1 r and 1 r get cancelled out. So can you see from here if I want to find out the total magnetic field due to all the elements over here, so will it be like this? Acha, what is the direction? Will you be applying right hand thumb rule or will you be applying converse of RSTR over here? Can you see the direction of current is going clockwise? The direction of current is going clockwise, right? If the direction of current is going clockwise, then the magnetic field thumb was pointing inside. It's not necessary it will always point inside. You have to check the direction, okay? So I'm used to this. So anyways, it will be integration of dB. So mu naught by 4 pi capital I by R will be coming out, and it will be into integration of d theta. Yes or no? So can you see from here B is equals to mu naught by 4 pi into I by R into theta. Where please remember here. Oh sorry, it should be fine. Because the total angle was how much? Guys, do you remember the total? The limits will be from plus 5 by 2 minus 5 by 2, right? So can you see it will be 5 by 2 minus 5 by 2. So ultimately, is this clear, guys?
Yes, sir.
Yes, sir.
Please write it down. Not a part of your school syllabus, but the derivation is required. If someone tells you to draw the special case for a full circular loop, or coil, B will be, acha, what will be the value of phi for the whole loop? Please remember phi should be in radians. Phi is never in degrees, it should be in radians, okay? So B for the whole ring, if I say if you have a circular coil or a circular loop over here, which is having current like this. So can you see the direction of current is? Direction of current, anti-clockwise. What should be the direction of magnetic field?
Outgoing.
Very good. And what is the radius? Let's say the radius is R. So what is the angle subtended at the center? Is it phi? Is it equals to 2 pi radians?
Yes, sir.
360 degrees if you remember. So always we take this radian thing. So the magnetic field in this case will be equals to mu naught by 4 pi into I into phi की जगह पे can I write 2 pi over here? So will it becomes 2 pi I by capital R? Yes or no? Yes or no, guys?
Yes, sir.
Yes, sir.
Yes, sir.
So this is how you'll do it. Shall I give you a school level derivation for this? Guys, do you have a at the center? I think you have this.
Yes, sir, we have.
Yeah, we do.
है ना, तो उसके लिए एक school level derivation I'll give you. अच्छा, for n turns, what will you do? You just multiply this thing by n into 2 pi I by एक से जितना बना उतने को n से multiply कर दो. Can you see the difference between this and the previous one? Can you see here? If it is an infinitely long wire, it is 2 I by R, whereas when it is a ring, it is 2 pi I by R. So can you see? अच्छा, किसका ज़्यादा है? Which has a greater magnetic field? So if you have an option of a wire to create a ring or a wire, which should have a greater magnetic field? Which should produce a greater magnetic field? So will the ring produce a greater magnetic field at its center, or will the straight current carrying wire produce a greater magnetic field? And this will produce. No? Pi se multiply. You multiply it 3 times, right? Yes or no? So anyways, this is pretty much clear. school level derivation I'll do, and in the next class we'll do some more derivations and then some applications of this question. Okay, I think that's it. And then you have solenoid and toroid. Once you're done with solenoid and toroid, then we'll start with the application part and using Ampere's circuital law as well. A school level derivation mein, guys, do I need to consider each and everything? Guys, shall I
Yes,
write the
sir.
whole statement? Let us consider a circular wire, a circular loop, circular current carrying loop of a radius capital R, and let us consider the current carrying circular loop of radius capital R and capital R and current I placed in free space. So the if we choose a small element over here, the dl vector will be like this. The angle between dl vector and r vector will be will be 90 degree. So you'll write dp is equals to mu naught by 4 pi I into sine of 90 degree by capital R square, because that was the length of distance. So the total magnetic field at the center is B, which is integration of dB, which is mu naught by 4 pi I by R square. Sine 90 will become 1 and dl. So can you see? Acha. Can you see what is the length of, if say, let's say the element starts from here. So will, if I say the length of the whole element is 2 pi r. So if I integrate it from 0 to 2 pi r, will the whole length be covered? Yes or no? Yes or no?
Yeah.
So basically length to integrate karoge to you'll get 2 pi r, and ultimately your final answer will be mu naught by 4 pi into 2 pi I by r. You can cancel, sir. Can't we cancel out this 2 pi and 4 pi? Array, what's the point? Ultimately, when you'll use it in numericals, you'll have to use the value of then mu naught. Then mu naught ko you'll write it as 4 pi into 10 to the power minus 7. It's better to use mu naught as 4 pi, mu naught by 4 pi as 10 to the power minus 7. So use this as 10 to the power minus 7 directly and just calculate this. Remember this. Are you getting my point, guys? So 2 pi I by r. So this is your school level derivation. That's it. Can you see the school level derivations can be very small? You people are generally afraid of this thing, right? Hello?
Yeah, kind of.
Chalo. Is it clear? Any doubt?
No, sir.
Chaliye, theek hai. We'll continue in the next class. The next derivation is a little bit big. ये तो school level derivation हो गया. Now I'll do special cases, no? Special case number 1 is done. Now special case number 2 for half ring. Anji, for half ring, will it become like this? If suppose the current is going in this and I want what is the magnetic field in the center direction. What is the direction? Coming out, right?
Yes, sir.
The direction is coming out of the plane. So this is the magnetic field, and B is equals to mu naught by 4 pi into I by R multiplied by phi. What is phi over here in this case?
Phi.
So can you see, jab ring double thi, when you halved it, it became half. The magnetic field became half directly. Can you see, it all depends on the length of the wire.
Yes, sir.
If you do it quarter, then what will it become? For a quarter ring, for a half, for a semicircular loop. And always remember, if there are more number of turns present, then you just multiply it. Here there is no turn, okay? Here there is only just one wire. If you turn it again and again, then one wire will cancel out the other's effect, right? I by R into pi. So why it will cancel out each other's effect? Because one wire will be like this, which will be producing magnetic field like this. Yes or no? And the second wire, if you turn it from here itself, then the second loop, second turn which you make will have a current like this, right? Yes or no?
Yes.
It will have the current in the opposite direction. They will cancel out each other's effect. So that is why there is no loop formation in this case. Here also same thing. So I think this is pretty much clear to you people. The current carrying straight wire and the current carrying. In the next class, we'll see some applications which are based on these two, and then we'll do toroid and solenoid. And there is one more, on the axis of a circular loop, and you'll find it similar to the electric field on the axis of a charged ring. You remember? K into lambda into x upon under root of r square plus x square to the power 3/2. ऐसा कुछ याद है? Something like this came. So here also something like this will come. So anyways, is this clear, guys? Any doubt?